Hello, and welcome to the first video for 3.1, the properties of equality. Okay, so many of us at this point in our mathematical career know how to solve an equation and find x or y or p, whatever variable you're trying to solve for, and kind of do so by one cardinal rule. What you do to one side, you have to do to the other. And that's kind of the theme of this first section here. So those are officially called the properties of equality. It's that big idea that what you do to one side, you have to do to the other. Okay. It applies to all of our operations. Go ahead and write that word down. It's pretty important. Operations. Now, don't worry because you definitely know what an operation is by this point in the game. Some operations include addition, subtraction, multiplication, division, square rooting, ... Okay, so anything that is a mathematical performing idea, right? Like you actually add. It's a verb, okay? So those are our math verbs. Those are our operations. The properties of equality state that whatever operation you do to one side of an equation, you have to do to the other side as well, okay? Now, the formal properties of equality. Okay, we can start with the three that kind of rope together here called reflexive, symmetric, and transitive. Fancy, fancy words. For reflexive is basically any number is equal to itself. Well, duh, right? You're equal to you. A is equal to A. Symmetric property says if you have A equal to B, then B is equal to A. So that gives us the ability to write X equals 2 or 2 equals X. They're the same thing. Okay, that's symmetric. Think, mirror property there. Transitive just kind of like a train. That's the way I think about it. If A is equal to B and B is equal to C, then A is also equal to C. So it's kind of like, if A and C are both equal to B, well, then A and C have to be the same thing. If X is 2 and Y is 2, well, then X and Y are the same thing. That's the transitive property. So that's just kind of the introductory part of equations in general. After that, you get much more familiar with your properties. You've got sorry, I'm going to zoom out here. You got the addition property, subtraction property, multiplication, and division property of equality. So basically, any of our four main operations you can do to one side as long as you do it to the other, and you won't change the equalness of the equation. If x equals 2, well, x plus 2 will equal 2 plus 2. Okay, so it's the same idea there with addition, and we're going to look at that a lot more. The only technicality you want to watch out for, division, you can never divide by 0. That's when things start breaking down. Dividing by 0 doesn't even make sense. And then you've got some more on the next page here. Substitution property, commutative properties, associative properties, distributive properties. These are probably not things you've never heard of, so you've definitely seen these in years past. Substitution is basically the idea that if you know x equals 2, then anytime you see x, you can replace it with 2. Okay, so once you've solved for a variable, plug it in. This is the plug it in property. So this is plug it in. Woot. Commutative, both of addition and multiplication, means you can turn it around, right? 2 plus 3 equals 3 plus 2. So if you want a number example, 2 plus 3 equals 3 plus 2. We all know this to be true. We know that's not true of subtraction and division. When you reverse for a subtraction and division, you get the negative version, right? So those would not have the commutative property. Same thing applies with the associative property. You can do that for addition and multiplication, meaning if I did 2 plus 3 plus 5, it doesn't matter what order I do 2 plus 3 plus 5. I could do 2 plus 3 and then add 5, or I could do 3 plus 5 and then add 2. I could do it the other way. So whatever would be faster for me, right? It's the way you combine things. Same goes for multiplication. 2 times 3 times 5 is the same no matter whether you do 2 times 15 or 5 times 6. You both get 30. So this, again, does not apply for division and subtraction. If you subtract things in a different order, you would not see the same result. If you multiply things in a different order, you divide things in a different order, you would not see the same result. So we don't have an associative property of subtraction or division. The last one, everybody loves to call it distribution, the swooshies, whatever you want to call it. This one's a big one. Put a star by this guy because he leads into factoring a lot. And we all know we love ourselves some factoring. We're not going to touch on factoring until about Unit 5, but it's very important to remember that this is the idea of factoring, okay? Distribution. If you have something on the outside, something that's being multiplied to two different things, then you are more than welcome to multiply it to each of those things. You distribute, you pass it out inside the function, okay? Or I'm sorry, inside the expression. Those are our properties. That is what 90% of algebra boils down to. This like one total page of rules. This is your toolbox. These are the things that you use to solve equations. You take these and you do more with them. The only other thing that you might use a lot is PEMDAS. Please excuse my dear Aunt Sally. So for those of us who maybe have never heard it that way, they're new to the school, new to the district, whatever, please excuse my dear Aunt Sally. That is the order we do operations in when we're when we're simplifying. So this is for simplifying, meaning I have just a string of numbers and I can plug it all in the calculator. These are what calculators do. Parentheses, exponents, multiplication, division, addition, and then subtraction. Notice it's operations again. Okay, so these are our order of operations, as they are formally called. You need to do it in that order. Non-negotiable. Has to be done in that order. Multiplication and division can be switched. Addition and subtraction can be switched thanks to that commutative property. Other than that, though, it is PEMDAS. These rules up here are for solving. The ones in ones in print are the ones where you have an x that you need to solve for. Okay, now they do apply universally, don't get me wrong, but that's just normally where you would see them being used. All right, let's dive into some examples here. More often than not, in real life, it is more important to know why you are doing something or whether you are allowed to do something or to prove that you can do something than to actually do it. Okay, so in this very first example, notice the actual equation has already been solved. We don't know what there's no ambiguity about what x is. It's already been solved. X equals -4. What our job is to fill in the missing reasons why x is equal to -4. Okay, so you're going to see this original equation that's just like given. Sometimes it says, yeah, there you go, just in there. What happened from here to here that produced this new equation? Well, what happened was we realized that addition of 22 was something that we could get rid of by subtracting a 22. But again, because of the properties of equality, I have to do that to both sides. And that idea was the subtraction property of equality. And feel free to abbreviate, feel free to just write subtraction property, that's okay. We know what you're talking about. And then what happened from here to here? Well, we realized multiplying -7 to x, you can do the opposite. You can divide -7 to both sides, and you will receive, and we wouldn't change the equality of the equation because I'm allowed to do the division property of equality. Why can't I undo operations this way? This idea is called using an inverse. An inverse, a word that may make you cringe from last year in secondary math 3, but it is an inverse, an opposite. Think it's different than an opposite, so be careful. But an inverse operation, we'll even go right operation, an inverse operation there. Notice addition is undone by subtraction. Multiplication was undone by division. Division, excuse me. And so what happens is those inverses cancel each other out, and that's why we're just left with -7x. Here, the -7s cancel each other out, and that's why we're just left with x. But again, according to the properties of equality, that also has to happen on the other side. Okay, so we're using inverses on one side and equating them on the other. All right, let's try this again. Let's see if we can figure out which inverses we need and why we can do that. What is the property that we can use for it? So this one's kind of an uglier looking equation, right? Just reminder, another way to write this is you could pull out the 1/6. Okay, that is another way you could write this equation. You can definitely move fractions that way thanks to the associative property, okay? Dividing by 6, same thing as multiplying by 1/6. Okay, same exact thing. Alrighty, over here, how did we go from here to here? Let's just double check that this did, in fact, follow the right format. Well, we've got a -3 on the outside, and so it looks like we could add 3 to get rid of it. Now, why would you want to start there? Why would you not want to do something with the 6? Because the 6 is uglier. The general rule is it's easiest to do something from the outside in, like the farthest away from your variable towards it. The reason for that is you have to watch out for that distribution property, okay? If I were to do something with the 6 right now, I would have to do it not only to both sides, but to each term, and that would be really tricky. I'd get a lot of fractions or a lot of bigger numbers, okay? And so it's just easier most of the time. It's not wrong, but it's easier if we go from the outside in. So it's not wrong or right or anything like that. You could do the 6 first, but it's just faster. Smaller numbers. All right, and that is indeed what they did here because we resulted in a 7 on the other side after adding 3 to both sides. Cool. So then what happened here to here? Right now we've got a times 1/6 or I'm sorry, negative 1/6 or dividing by 6. It looks like they chose to ignore the negative at this point. There is a negative on the outside. They did not times by -6. Had they done that, the negative would have also canceled. So here it looks like they just multiplied by 6 to both sides. They used the inverse of dividing by 6. And that's how we achieved a positive 45 on the other side. Now, what property is that? Of course, I could look back at this big list, but what did you do? What operation is it? It's multiplication. And so the the equality property is multiplication. Yes, math is not English. They don't try to do these big, long soliloquies of names. It's literally just named because it's multiplication. So there we go, filled in multiplication. And then how on earth is this the division property? What on earth does that mean? Oh, I see. Dividing by -1. That's what happened there. They divided the negative. Because remember, there is actually no such thing as negative x. That's not a thing. Negative means here you have -1 times x is equal to 42. So I always run into people, they're like, how do I get rid of the negative? It's like, you don't, bro. It's not a negative. It's not a free-floating negative just in space. It's a -1. How do you get rid of the -1? You divide by -1. Okay, now you also have a secondary option. You could multiply by -1. That's kind of one of the cool things about -1 is that it has that ability. But here we already know they chose division, so we divided by -1. All right, let's try one on our own now, and then we'll go into just solving. We'll get a little more of this justification idea going. Example number 3 on the next page here. They did not solve it for us. So there are actually multiple ways to do this. There's a couple things we could do. Good rule of thumb, though, start as far away from your variable as you can. I think this guy is as far away as I can on one side, right? I mean, I can't really do anything with the 10 except, move it, but that doesn't help me. So I want to get things away from x. I want to start solving for x. I want to figure out what that x is equal to, but +4 is the farthest thing that's in the way. So how do you get rid of +4? What's the inverse? Inverse of addition is subtraction. So I'm going to subtract 4 to both sides. That would be, shocker, the subtraction property of equality. And what would we be left with? We'd be left with no 4 idea, kind of the point of choosing that. We'd be left with 5x minus 2 equals 6. Booyah. All right, from here we have some choices. I have a lot of students who look at a situation like this and they automatically assume distribution property, which is totally something we could do. So let's go ahead and do distribution property. Property of equality. And what would that say? That would say, okay, I've got this parentheses, I've got something multiplying to both aspects, both terms of this binomial. So how can I make this simpler? I could distribute it in. Definitely do that. All right, beautiful. Now that's not a to both sides situation. It didn't clean any, or it didn't solve anything, didn't move anything away, but it did clean it up a bit, right? It made our life a little bit easier because now I can identify a 10 that I might want to get rid of with a positive 10. So I've got subtraction of 10. The inverse would be addition of 10, and that would cancel it out. And I'd be left with 5x equals 16. All right, and that would be the addition property. Try not to get too lazy about this, okay? You can't just write add or subtract or distribute. You actually have to write like this is the property. So subtraction, minimum, distribution, addition, okay? All right, last thing, and I'm looking here, it's pretty small now, but I've got one more thing I need to do. I've got 5 times x, so if I divide it on both sides, I get divide by 5, divide by 5, and I have a lot of students who will divide that out, and if you do, and that's okay, you do get a terminating decimal. There's nothing wrong with decimals. Decimals are beautiful. Decimals are used every day. Decimals are used for money. We love money. But if it's not a terminating decimal, it just gets a little tricky to write. So if you end up getting something like 1/3, please keep it as 1/3. Don't write 0.3. It could change your answer later on if you're using something. In this case, either one is fine. 16/5 or 3.2. And that was the division property. Now, there was a secondary way to do this, as I mentioned. Right about here, we did not have to distribute. Okay, that is not the only thing we could have done. So right about there, I'm going to go ahead and do a different color. We could have simply divided the times 5. Okay, so we had 5x minus 2 equals 6. And this was, we'll just say subtraction, so they're just picking up a secondary way. Okay, and I could divide the 5 to both sides. That is my choice here, because technically the 5 is more on the outside, right? Until I do the distribution property, it's not the last thing I do. It is more on the outside. I could do that. And so I get x minus 2 equals 6/5. And I could use division first. Oops. There we go. Now I would add 2 to both sides. And as a decimal, that would also be 3.2. So however you want to do it. So this is now addition. Notice that all that did was switch the order we did addition and division, right? So we still use the same operations. The operations didn't change. It's just by putting in that distribution, you could argue, avoiding adding fractions, I don't know, whichever one. But either one's equally as correct. We ended up at the same answer. Hooray. Alrighty. In the next video, we're going to do some more solving techniques. We're not going to write down the justification steps. We're just going to go ahead and solve just some things you'll see. You'll notice these ones all have multiple x's. See you then.